My name is HRISHIKEsh.
Myself, RAKESH.
My name is PANKAJ.
We are final year students of ECE department from VELTECH University.
We have done our final year project in deep sea mining of National Institute of Ocean Technology, which is located at Velachery in Chennai.
Let's see one small video about deep sea mining.
Our project title is Analysis of TCP/IP Communication and Analog Signal Video Feed through Slip Rings for Deep Sea Applications. Our internal guide is N. Vignesh Prasanna. Our external guide is P. Muthuvel, Scientist D, who works at DSM NIOT. Abstract. Crawlers are used for deep sea mining. A fiber optic cable connects the crawler with the control module. Frequent failure of data communication link has been observed, whereas there is a proper video transmission. The transmission of system signal to the shipboard system is transmitted through the Cat5 cable. We intend using Cat6 cable in its place. In the winch system, an electrical slip ring is used presently. We recommend replacing the electrical slip ring with optical slip ring. Replace copper carbon brushes with gold brushes, which provides better electrical conductivity. The existing system. In the existing system, the transmission of data takes place from the system module to the slip rings through the Cat5 cable. The brushes inside the existing slip ring are usually made of either carbon or copper. The slip rings presently in use are electrical slip rings, which has high degree of mechanical losses. Loss of data occurs when time to leave TTL bits in a TCP/IP frame becomes 0 before reaching its destination. Here you can see the schematic diagram of the entire setup. The bottom part consists of the subsea system, which is connected through the umbilical cable to the shipside system. In the subsea system, you can see the NI controller, which is connected to all the sensors, which provides all the video data transmissions, and which is again passed through the umbilical cable. The umbilical cable consists of optical fiber along with power electrical cables. On the right hand side, you can see a schematic diagram of the same setup. This is a figure. This is a schematic diagram of the winch system. The winch system consists of a rotary drum, which is used to wind the umbilical cable. The umbilical cable is required to extend its length or shorten its length as per the movement of the crawler is required. So inside the winch system, the receiver modem is located. The receiver modem is again connected to the slip ring. This is a block diagram of the entire setup. On the left hand side we can see the subsea controller. The subsea controller is connected through primary 4 video and RS-232 communication links to the shipside system. The shipside system is again connected to the RF MOOC slip ring and RF Ethernet modems, which is again connected to the control desk. The proposed system. In the proposed system we have two approaches. One is the hardware approach, the second is the software approach. In the hardware approach we have proposed the following points: analysis of cables category and its parameters, which is used for TCP/IP communication, using an amplifier before the optical signal is fed into the modem. Ensure that the slip ring arrangement has proper brush contact at all times. Software approach. Ensure that the TTL time to leave bits are assigned 0 before the data frame reaches its destination, to measure the total time taken for downloading the data at shipside control panel. The components which we are using for the simulation purpose are as follows: PC controller, receiver modem, both TCP/IP and video, transmission modem, both TCP/IP and video, slip ring, Cat5 and Cat6 cables, NI controller, CFP 2120, AI 610, DI 330, RJ45 patch cord, LabVIEW software, frequency generator, dual power supply. This is a schematic diagram of the full setup of TCP/IP and video communication which we are using in our laboratory environment. We cannot do the entire experiment in real-time conditions, so we are trying to simulate it in laboratory conditions. So there is a receiver modem which is connected through a umbilical cable, the transmission modem. For the umbilical cable we are using a optical fiber, and which is the transmission modem is again connected to a NI controller. The receiver modem is again connected to the rotary part of the slip ring, and the stator part of the slip ring is again connected to the PC controller. In our first simulation test, we have carried out ping analysis on both Cat5 and Cat6 cables alternately. As you can see, in the Cat5 cable we have found that there is a significant amount of loss of data packets. The loss is amounted to 22.3% of the total packet transmission. As you can see, in the Cat5 cable there is a constant loss of 22.3% of the total data packet transmission. In our next stage, we have replaced the Cat5 cable with the Cat6 cable. With Cat6 cable, we have found that there is a 0% loss in the transmission of packets, which we can see in our next video. In the Cat6 cable, as you can see, the loss rate is 0%. So thus we can conclude that the Cat6 cable is better than the Cat5 cable. We have further carried out simulation using LabVIEW software. With the Cat5 cable, we have found that there is significant amount of attenuation and noise, whereas the Cat6 cable shows ideal voltage signal characteristics. In the LabVIEW software, we have designed a circuit for testing purposes of the voltage signal analysis. Here we can see the voltage characteristics of the Cat5 cable. So we can see there is a significant amount of attenuation and noise in the Cat5 cable transmission. The following are the conclusion points which we have arrived after considerable simulation tests. The Cat6 cable will provide more reliability to the TCP/IP communication network with low packet data losses. Gold alloy brushes will provide high electrical conductivity. An electro-optical slip ring has lesser probability of data loss during transmission that eliminates the timed out error during TCP/IP communication. Future enhancement. For the future enhancement, we have listed out the possible 4 different ways in which we can improve the existing system. Different pathways for the power supply cables and the TCP/IP cable. This will eliminate any electromagnetic effects coming from the power supply cables in the TCP/IP cable. Improvements in design of the Cat6 cable. Currently the Cat7 cable is in design stages, which will significantly improve the communication parameters more than the Cat6 cable. Improvements in design of the slip ring. Presently we are using an electrical slip ring which can be improved further by using different types of materials in the construction of brushes. Moreover, the optical slip ring can boost up the signal in very high quantities. Improvements in design of the crawler, a fully automated mining rover, can also go a long way in improving the whole communication network. Thank you.